Alright guys, I hope you guys are doing good. So this is section 3.9 from the book, okay? And this section we'll talk about a linear approximation and differentials, okay? So first of all, linear approximation, why do we need this? So sometimes your function fx looks like very complicated, and if you want to find the height of the function, this is the function fx, right? If you want to find the height of the function at c and around c, for example, I want to find the height of the function at this point, which is close to c but on the right side. Similarly, I want to find the height of the function at this point, which is close to c but on the left side, right? So how do I find out the height? Because this function is so complicated, the equation may be complicated, so it may be harder to find out by plugging in that point to the x in the function, right? What we do instead is we find out the equation of the tangent line, okay, at the point c, and then find the height of the tangent line instead of the height of the function, which is suppose that is complicated form. What we do is we find the height of the tangent line near c. That height will not be that different. It depends on the function. So if you want to find out the height of the function very close to c, let's say here, or very close to c on the left side, let's say there, then that height can be well approximated by the height of the tangent line, right? So that's how it works. So what we do here is, so let's find out, so this is c, so what is the coordinate of this point? This point will be, basically, let me write down that this point will be, this point basically is c and then fc, right? So I want to find out the equation of the tangent at c comma fc. So it is like x1 y1, right? So what is the equation of the tangent line? It is like y minus y1 equals to f prime or m, you can say m, and then x minus x1, right? So f prime at x1. That's the equation of the tangent line. So f prime is the slope m. So y minus y1 equals to m, x minus x1. You guys know this. Now, so if you plug in that x1 is c and then y1 is fc, you'll get y minus fc equals to f prime of c is the slope and then x minus c. And if you solve for y, you'll get y equals to, you add fc on both sides, right? So if you add fc on both sides, this is what you get, y equals to fc plus f prime of c times x minus c. This is what you get. So we denote this by tx because this is the equation of the tangent line, right? So y is basically fx, function of x, but here what we write is tx, just to note that this is the equation of the tangent line, okay? The value of c will be given to you, that is x equals to c, right? And you just plug in the values there. Okay, let's see one example. Use tangent line approximation for fx equals to root x. This is the function, fx equals to root x at x equals to 4. So this 4 is basically the c, right? Also approximate the value of fx at x equals 3.9, 4.01, 4.1, and so on. So what it is saying is, maybe if you are asked to find out what is the value of fx, this is the fx, when x equals to 4. At x equals to 4, it is 2, right? Because root 4, that is 2. But it is hard to find out at 3.9. If you plug in 3.9, then you cannot do it directly. You'll have to use calculator for this. And at x equals to 4.01, also it is hard. At x equals to 4.1, it is not straightforward. So how do we do that is, we'll find out equation of the tangent line at x equals to 4, and then use that tangent line to find out the value at x equals 3.9, 4.01, 4.1, and so on, okay? That is that equation to find out that, okay guys? Okay, all right. So calculate these values using calculator too. So this is the using calculator. So this is using calculator. This is using the tangent line, okay? So let's find out first find out f prime x. So what we have is fx is root under x, right? So how do I find out the tangent line? This is basically x to the 1/2. So to find out the derivative, it is like 1/2 and then x to the 1/2 x to the 1/2 minus 1, that is negative 1/2, right? So if you simplify this, it will be 1/2 root under x. This is the derivative, right? Now we need to find out the equation of tangent line. To find out the equation of tangent line, what is c? X equals to c is 4. So it is y equals to f at c. F at c is 4, right? So it will be like f at 4 is root under 4, right? Root under 4 plus f prime at 4. What is f prime at 4? F prime at 4 is 1/2 root under 4, right? 1/2 root under 4. That's what you get. And then times x is, just keep x and then minus 4. So if you simplify this, you will get tx equals to you will get, so you'll get tx equals to root 4 plus 2 1/2 root 4 and then times x minus 4. So this will be like 2, right? And then plus, what is, how much is that? 1/2 times 2, right? 1/4 times x minus 4, right? If you simplify this, how do I simplify it? It will be like 2 plus 1/4 x minus 1/4 times 4 is 1, right? So that will be 2 minus 1. So it will be basically tx equals to, you get a 1/4 x plus 1, right? Because there is 2 and then 1/4 times negative 4 will be negative 1. So 2 minus 1 will be 1/4 x plus 1. Now, so let's plug in this value of x, 3.9, 4.01, 4.1 at fx. Fx is that, you use calculator to find out that. And then at tx, you can use calculator, but you need to use this equation to find out tx, okay? You will see that those two values are almost the same. Why? Because we are using the tangent line to approximate the height of this function. So close to that point, close to the tangent, that the point where we found the tangent, the height of the tangent and the height of the function are almost the same. That's what we call linear approximation, because we draw a tangent line at C and then we use tangent line to find out the height of the function, okay? So when 3.9, okay, now we use this function, the given function fx equals to root x and the tangent line, and then check if you get the similar values near x equals to 4. Similar value means the value of the function using calculator and value of the tangent line, or you can say height of the function and height of the tangent line close to the point x equals to 4. I took 3 points, 3.9, 4.01 and 4.1. I want to see whether these two values are equal or not. Basically they should be almost equal, they should be close, okay? So what I did, I used calculator for fx equals to root x, and then I use root under 3.9, root under 4.01, root under 4.1, and I found these values. And then the tx is basically this equation. I use this equation, okay? I take x equals to 3.9, I got 1.975. You see that they are almost the same. And when I take x equals to 4.01, I got 2.0025. Similarly, at x equals to 4.1, I got 2.025. Basically, these values are almost the equal. So you can say that you can approximate the value of a function by drawing a tangent line at a point, and you can approximate the value of the function around that point, okay? All right.